Okay, morning everyone. Just going to go through some of the work on periodicity that we've covered in Year 12. So we're going to look at trends and patterns as you go across the periodic table, looking at ionisation energies and successive ionisation energies, looking at melting point and linking that to the structure and bonding. And then when we've done that, on to group 2, and then after group 2 onto the halogens in group 7. So we're going to start off today by going through our questions that we printed off last time. So first one, chlorine and bromine are elements in group 7 of the periodic table. Chlorine is used in water treatment. State one advantage and one disadvantage of using chlorine in water treatment. So it's obvious the advantage is that it kills bacteria, which you'll know from GCSE. Again, from GCSE you'll know the term potable water, which basically means making water safe to drink. And we do that by using the chlorine to sterilise it. A disadvantage of using chlorine would be the fact that chlorine is considered to be toxic, so we need to be careful with the amounts of chlorine used for that. Okay, so our next bit then. The electronic configuration of bromine contains outermost electrons in the 4th shell. So for this part we need to look at the periodic table and look at where we go after 3p6. So on the periodic table, 3p6 takes us as far as argon. So to get as far as bromine, we've got to go through the 4s electrons, then all the 3d10, and then we're back into the 4p there. So looking at this one, beyond that it goes 4s2, which fills first, 3d10, and then 1, 2, 3, 4, 5. So 4p5. Just as a bit of a reminder, you can also do, instead of writing out all of that, you go to the previous noble gas, which is argon, and you could put that instead of it. Okay, so part C. Displacement reactions can be used to detect bromide ions in solution. A student has a solution that contains bromide ions. The student carries out the following experiment. She bubbles some chlorine gas through a sample of solution and the mixture changes colour. Then adds an organic solvent, cyclohexane. She shakes the contents and allows the layers to separate. So again, going from the halogens, at the top of the group we've got fluorine, chlorine, bromine, then iodine. We know that the reactivity increases as we move up the group, which means that in this reaction we're looking at bromine and chlorine. Obviously the chlorine can displace bromide ions from solution. So in step 1 we've got chlorine gas, so Cl2, being reacted with the solution that contains bromide ions, but because it will be displaced, the chloride will form its ions, chlorine will form its ions, and then you get Br2 as well. To balance it, get that. So the other thing to remember about this is the fact that these have all got colours when they're in solution. So this is a very pale sort of yellowy green colour. The bromine is an orange colour in solution, and the iodine is also gives you an orange colour in solution. So the cyclohexane layer floats on the top of the test tube. So if you've done this in a test tube, you've got your reaction going on in there, your displacement reaction, and then the cyclohexane sits on the top. Now, because you formed bromine, which we just said is actually orange in colour, then what happens is this is almost colourless, turns into something that's orange. So that top layer there, the cyclohexane, should give you an orange colour. Okay, on to the next one. So chlorine reacts differently with the dilute and concentrated aqueous solutions of sodium hydroxide. When chlorine reacts with dilute sodium hydroxide, one of the products is sodium chlorate 1. So that 1 there refers to the oxidation state of the chlorine in this compound. So if it's sodium chlorate, so sodium is always a 1+ ion, oxygen is always a 2- ion, so the chlorate, the chlorine part of it, has also got to be 1+ in order to cancel out all the charges to give you the formula NaClO. So when chlorine is reacted with hot concentrated sodium hydroxide, a different reaction takes place. One of the products is NaClO3, which is a weak killer. In the reaction, chlorine has been oxidised and reduced. So a bit of a clue with this one. A term that is used to describe a redox reaction in which the element is both oxidised and reduced. This is a disproportionation reaction. Write equations for the two reactions of chlorine with sodium hydroxide. So a key part to this is the fact that we talked about bleach, and we would have learnt about some of the products that are formed when bleach is formed. So the equation with the dilute sodium hydroxide, so we know we're going to form this as one of the products. So it's going to be Cl2 plus NaOH goes to NaClO plus your sodium chloride salt plus your water. So to balance this is pretty straightforward. We need to put a 2 in front of this, and what else do we need to do? Put a 2 in front of that, gives us 2. I think that's it. Hopefully I haven't missed anything on that. I guess right. Okay, the next one with the hot concentrated of sodium hydroxide. So Cl2 again plus NaOH goes to NaClO3, and that's come from the question there, plus NaOH plus H2O. Now to balance this I think is a little bit more tricky, so we're going to do that at the bottom of the page. I'm going to show you a way how to do this with balancing with oxidation numbers. So Cl2 plus NaOH goes to NaClO3 plus NaOH plus H2O. So we know that in this reaction it's the chlorine that is both oxidised and reduced because it's a disproportionation reaction. So if we take a look at what the oxidation states are in each of the chlorine species we've got, written that wrong. So we've got chlorine there, element in a standard state, so oxidation state is 0. The chlorine in this part, so if Na is 1 plus and each of the oxygens are -2, then the chlorine must be +5. And in this one, the chlorine is -1. Now overall, we've got to get this to balance. So if I've got 5 pluses and only 1 minus, I need to have 5 times everything that's in that in order to get that to cancel out to come back to 0. By putting that 5 in front of there, everything else kind of just falls out now. So I've got 6 sodiums, so I need to put a 6 in front of that. I've now got 6, let's have a look, I've got 6 hydrogens, only 2 on this side, so I'd need to put a 3 there. Now if I've got, count out the number of chlorines I've got 5 chlorines in there, 1 chlorine there, so that's 6, so I need to put a 3 on this side. So the balance in this equation is a little bit more complicated, so it becomes 3, 6, nothing in front of that one, 5, and 3. Okay, so chlorine forms another chlorate called sodium chlorate 7. So again, that 7 refers to the oxidation state of the chlorine using the manufacture of matches. State the formula of sodium chlorate 7. So it'll be Na, Cl and O, because the 8 part refers to the oxygen. So the sodium is 1 plus, the oxygen is always a 2 minus. So we've got to figure out a way how to get this to balance. So let's have a think about this. So if we've got no charge overall, if this is +7, so we've got 8 pluses altogether, so it's going to be NaCl, and to make this 8 minuses we need O4 on the end of it. Okay, so that's the first question gone through. I'm going to do them individually, so please make your way through that and let me know if there's any problems.